Human conversation happens at a rhythm of about 200 to 300 milliseconds. If an AI takes longer than that to respond, the magic dies. It feels like a machine, not a partner. But Google's Project Astra is breaking that barrier, achieving sub-250 millisecond latency in real-world multimodal interactions. This isn't just a faster chatbot, it's a fundamental shift in how computers perceive the world. We are moving from type and wait to see and do. And the infrastructure making this possible is genuinely one of the most impressive engineering feats of the decade.
To get this kind of speed, Google had to rethink the entire Android stack. Android 16 is rumored to introduce dedicated real-time threads specifically for multimodal input processing. This allows the system to prioritize camera and microphone data above everything else. It ensures the AI sees what you see the exact moment it happens, without the usual OS overhead. It's about cutting every microsecond of dead air between the glass and the cloud, and that's where the hardware comes in.
Enter the Pixel Astra glasses. These aren't just a display. They are a sophisticated sensor array designed to feed the Astra engine a constant stream of high-fidelity data. By moving the sensors to eye level, Google is giving the agent your exact perspective. It's the ultimate first-person view for an AI, and it's critical for the sub-250 milliseconds goal. But processing that much video data in real time is a nightmare for battery life and heat. So how did they solve it? The answer lies in a clever hybrid compute model.
The secret is the Edge Cloud Hybrid. The Pixel's onboard TPU handles the initial vision processing, things like motion detection and object recognition. This pre-digested data is then beamed to Google's massive Gemini servers for the heavy reasoning. This split-second handoff is what keeps the latency so low. By only sending the most important visual tokens to the cloud, Astra saves bandwidth and time. It's like sending a summary instead of the whole book.
This speed changes the relationship. When the AI responds instantly, you stop thinking of it as a tool and start treating it as an extension of your own senses. We've spent decades learning how to talk to computers. Now, for the first time, computers are learning how to live at our speed. And that's just the beginning. Because once an AI can see and respond in real time, it starts to remember things. It starts to understand space. And that's where things get really interesting.
Astra's multimodal perception pipeline is a masterpiece of engineering. It doesn't just process video, it processes video, audio, and sensor data simultaneously in a single stream. In older models, these were separate systems that talk to each other. In Astra, they are unified. The AI hears the context of what it sees without any translation delay. This is why Astra can understand a joke you made while pointing at a specific part of a complex diagram. It's a level of situational awareness we've never seen before. To maintain that 250 millisecond speed, Google uses a technique called continuous encoding. The camera feed is constantly being turned into mathematical tokens even before you ask a question. This means when you finally do ask, "Where did I leave my keys?" the AI doesn't have to go back and watch the footage. It has already processed the meaning of those frames. It's a rolling window of understanding. And managing that window without melting your phone's processor is the real magic trick.
The hybrid compute model is also a privacy win. Sensitive tasks like face recognition or reading personal text can stay entirely on device within the protected kernel of Android 16. Only the abstract, non-identifiable tokens are sent to the cloud for high-level reasoning. This ensures you get the power of a supercomputer without sacrificing your personal data. This balance of local security and cloud power is the blueprint for all future AI hardware. It's the only way to make an agent that is both useful and trustworthy.
But what about when you're in a tunnel or a dead zone? Astra is designed to gracefully degrade. It switches to smaller, local models that can still handle basic tasks without a connection. This offline intelligence is powered by Gemini Nano, a version of Google's model optimized for mobile silicon. It's not as smart as the cloud, but it's fast and always there. The transition between edge and cloud is seamless. You won't even notice the handoff. You'll just notice that your assistant never stops working.
This infrastructure is the foundation for something much bigger than a voice assistant. It's the nervous system for a new kind of computer interface. We are moving away from apps as you know them. Why open an app when your agent can just see the problem and fix it? This is the end of the menu-driven era. But to truly replace apps, the agent needs to do more than just see. It needs to remember. It needs a sense of space. And that's where Astra's spatial memory comes in.
Spatial memory is Astra's killer feature. By constantly processing video, it builds a 3D map of your environment and tracks the objects within it. When you ask, "Where did I cut my glasses?" Astra doesn't just search a database. It recalls the last frame where it saw the glasses and points you to that exact 3D coordinate. It's like having a perfect photographic memory that is searchable in real time. It turns the physical world into a queryable database.
This leads us to the universal agent. Unlike current LLMs that wait for you to type a prompt, a universal agent is proactive. It anticipates your needs based on what it sees. If it sees you looking for your keys, it doesn't wait for you to ask. It highlights them on your glasses. If it sees you're about to miss a bus, it tells you before you even check the time. This is a fundamental shift from reactive to proactive computing. The computer is finally looking out for you instead of just waiting for instructions.
By 2026, this will redefine the human-computer interface. We won't use computers anymore, we will collaborate with them. The screen is no longer the destination, it's just a layer on top of reality. This ambient computing means the technology disappears into the background. It's there when you need it and invisible when you don't. No more doom scrolling or neck strain. The challenge, of course, is trust. For an agent to be this proactive, it needs to see everything. Google's success depends on making that trade-off feel safe and valuable.
There are still hurdles. Battery life for all-day glasses is a massive engineering challenge. Heat dissipation near the temples is another. We aren't quite at the Iron Man hood yet, but the trajectory is clear. Every update to Android, every new TPU chip, and every breakthrough in model compression is a step toward this universal agent future. The competition is fierce. Apple and Meta are racing for the same goal. But Google's deep integration of Search, Maps, and Gemini gives them a unique.
So here's the big picture. Project Astra isn't just a demo. It's the first look at a world where computers have eyes, ears, and a memory of their own. And they're using them to help us navigate our lives. The sub-250 millisecond latency is the key that unlocks it all. It makes the AI feel alive. It makes the interaction feel human. And in 2026, it might just make the smartphone feel like a relic of the past. The question isn't if we'll use these agents, but how they'll change us once they're here. The future is looking fast, proactive, and incredibly bright. I'll see you there.